Good morning everyone. Myself Karmore, second year analytical student from Annamasarkami College of Engineering and Technology, Ashta. So today's topic is crashworthiness, stress analysis in aircraft and fuselage. Basically, mainly that is topic. Then basically the agenda for today is introduction of crashworthiness, stress analysis fundamentals, fuselage design and load cases, simulation and testing, impact on passenger safety. So we'll be talking about these points throughout the PPT. So what is aircraft crashworthiness? So basically crashworthiness is a point which has a major concern and a very vital and important role in the aircraft and basically the airline industries, aerospace and aeronautical industries. This is a very important topic which makes sure that the passenger safety is at the most priority and making sure that the ingenuity is added in such a way that if a certain component fails, that has to be failed in such a way that the machine won't harm the lives inside it. So basically, this is what our topic for today is. Fundamentals of stress analysis. So basically, this topic is relied on stress, strain, and material properties. So stress is basically force per unit area. When a certain force is applied to a particular object, due to that force, there is certain deformations and various types of forces act on that particular object, and various outcomes are seen. And therefore, stress is a very vital and important part of this test. Strain is basically the deformation of the material in response to the stress applied to the material. So basically, deformation is very important as it shows the crumple zone of a material and the material properties. Obviously, the material used in various aircrafts are vary as their application. For example, Eco-Large steel, 775 aluminium, carbon fiber, etc. And that is very important in order to showcase the material properties. On the basis of the material properties, the stress and the strain is implemented. And the fuselage design and load cases. So fuselage design is a very complicated process in which the fuselage is designed in such a way that it can handle at very high pressures as well as low pressures and can maintain its structural integrity with a long lifespan while giving its optimum performance while holding several lives in it. So basically it has various types of monocoque, semi-monocoque, it has stringers, bulkheads, formers, and new innovations has been done and the ingenuitive ideas has been implemented with the help of carbon fiber and Kevlar monocoques which has significantly increased the strength and reduced its weight and the overall lifespan of these products. And talking about the energy absorption mechanism, so that it is a very important thing which has to be taken into consideration. So progressive crushing, structural collapse, and seat deformation. So talking about the progressive crushing, so when a part, for example, a bulkhead crashes in the fuselage, so it has to crumple in such a way that it does not deform throughout its length. It deforms only a certain part which won't harm the passengers and the occupants inside. Whereas the structural collapse basically says how the structure is integrated in such a way that what are the angles that it is made into and what are the materials used in order to make sure that the structural integrity is 100% and not compromised, and it supports the progressive crushing. And the seat deformation. Seat plays a very important role in the fuselage, and seat design is not just ordinary seats, but they are designed in such a way in order to dissipate shock and absorb a lot of impact at the time of hard landings or crashes, in order to make sure the passengers are at most safety. Talking about the next point is simulation and testing. So before making the real life prototype, we first design the software in the CAD and then simulate it as shown in here. This is finite element analysis, FEA. So basically this, for example, a component is taken and it is broken down into thousands of n number of pieces, and that is gone through various testings. As we can see here, the red part which has been imparted to a lot of stress, whereas the green part is showing where the stress is not minimally reached, whereas the blue portion is showing that the impact is the minimum here. So according to these diagrams, an engineer can find out and basically implement this aircraft by implementation of all the information that is gathered from the simulations. And then comes the full scale crash testing. So basically a full scale plane 1-to-1 ratio is is mounted on a test rig, and various tested are done. For example, here we can see a bulkhead of the wing box is being tested. As the pulley leaves it, it swings down on the ground and smashes. And basically there are n number of sensors that showcases what are the impacts and what is the crumple zone that has been activated while the aircraft lands on its belly. And talking about the impact on passenger safety. So basically these all ingenuities are implemented in order to make sure that the human life is safe inside that engineering marvel. So basically it consists of 4 parts. So maintain survival volume, improve rescue access, reduce deceleration forces, and minimize post-crash hazards. So basically maintain survival volume is basically the fuselage that has to be saved and has to have that most integrity because the lives are constrained into that part of the aircraft, so that has to be very strong. Whereas in the improved rescue areas, there are certain rescue areas in the front and the back of the aircraft, and that has to be made sure that it has optimum strength, which makes sure that it does not crumple or fail at the case of an emergency. Reduce deceleration forces. So when there is in the cases of emergency landing or crashes, the forces should be dissipated in such a way that these rescue area access should be minimized. And minimize post-crash hazards. So when a certain aircraft has crashed or some malfunction has done, so the post result of it should not harm the aircraft much more. For example, the fuel lines and the risk of fire, that should be minimized, and that can be done with the help of proper material selection and engineering CAD design. And key takeaways in this presentation is stress analysis. So basically stress analysis is very important in order to make sure that a particular product outperforms its engineering CAD drawings and its material used optimized. In that the goal is energy absorption. So most of the energy should be absorbed and the crumple zone should be activated in order to make sure the occupants are safe. And the FEA simulation, as we talked in the earlier slides, the finite element analysis. So that is a very important and plays a very crucial role in order to make sure that the bulkheads and the stringers bear the maximum load of the aircraft and make sure that the passengers and the lives inside are safe. And continued research is going on till date and will further continue in order to make sure that the safety is being not compromised, and whereas with the safety the ingenuity also increases and more lightweight, strong, and a lot of ingenuitive thoughts will be put into it to make sure that the future air travel will be safe, secure. Thank you.